Section 11.5, looking at volume of prisms and cylinders. Our essential question: how can you find the volume of a prism or a cylinder? So we start with the same basic formula for both of these. Volume of a prism is area of the base times the height. So realize the capital B is the area of the base. So as the base changes, that's going to change, and you're going to have things that you're multiplying to get that area of the base. And this works for a right prism and a prism that is not right, which means that it's on a slant. The height and the base still work. So if it says right cylinder or not, right prism or right cylinder does not matter. Then a cylinder is still area of the base times the height. The difference is that here your base is always going to be a circle. So normally we'll see this as pi r squared, which is our area of a circle, times the height. When you're dealing with the prism, the first thing you want to look at is what is my base? And then how do I find that area? Cylinder, we're looking at what is our radius, what is our height. So as we look at example 1 here, okay, our first thing, we have a rectangular prism. So nice thing about the rectangular prism, it doesn't really matter what we call the base. A rectangle is going to be the base. So I can just multiply my length, width, and height. 11 times 4 times 5 gives me 220 meters cubed. In volume, our units are always going to be cubed. Then B, we have a cylinder. So I have a radius of 5, a height of 6. So I have pi times 5 squared times 6. And then 5 squared is 25 times 6 is 150. So 150 pi is an answer. It's an acceptable answer. That's our exact answer. If you're asked to multiply it out, you would do 471.24 meters cubed. Then C and D, we get into 2 other prisms, but here we don't have rectangular prisms, so we need to think about what the base is. Remember, the base is always your side that is not rectangles if you're dealing with a prism. So in C, the base is this front triangle here. Okay, that is the base of our shape. We could use the back triangle, it's going to be the same size. So area of a triangle is 1/2 base times height. So we have a height of 1, a base of 3. So I have 1/2 times 1 times 3. And the height of my prism is this 2 feet going back here. So we multiply this whole thing out, we get 3 feet squared. I'm sorry, 3 feet cubed. Then on our other shape here, the base is the top. I have prisms going around. The base is my shape here. So we have 6 sides. We have a hexagon here. That is a regular polygon. All the sides are 12 centimeters. So our area there is 1/2 ASN. Okay, A being my apothem, S being my side length, N being my number of sides. So I have an apothem of 4. Apothem of 4 because the arrow is coming down here. A side length of 12 and 6 sides. So I do 1/2 times 4 times 12 times 6. That gives me 144. And I have a height here of 7. So I multiply that by 7. And I get 1,008 centimeters cubed as my volume. Then E changes a little bit. It says find the length of a side of a cube with a volume of 64 inches cubed. So here we're working backwards. So in a cube, my side, everything's squared, right? We have a square base, we have square sides, so everything is the same length. So another formula we can look at here is s cubed, because our length times width is how I find my area of the base times the height, all of which is going to be the same side length. So s cubed equals my volume, which is 64 inches cubed. So we take the cube root of that. Okay, so the cube root of 64 is going to be 4. So my side length is 4 inches cubed. And remember, the cube, that would be saying that 4 times 4 times 4 is 16. Okay, and probably have a cubed root button on your calculator. If not, you can raise it to the 1/3. Make sure you use parentheses. Okay, but square root can actually be done as raising to 1/2. Cubed root could be done as raising to 1/3 if you don't have a cubed root button on your calculator. Then flipping it over, looking at our cylinders a little bit more here. So the first one, what we're looking for is the radius. They give us the volume of the right cubed is 1,253 cubic centimeters. We want to find the value of x, which is our radius. So our area, pi r squared times h, that's going to equal 1,253. You can multiply some things out here. I decided to divide by the height at first. So I get pi r squared equals 125.3. Then I divide by pi, which gives me 39.88. So then, since this is r squared, I want to take the square root of that. And my radius, or x, is 6.32 centimeters. Then our last one here says, for this part, says find the volume of a composite solid. Composite solid is made up of more than one of our shapes, right? So I need to have multiple formulas when I'm dealing with a composite solid. It's something that I can't just find by itself. This is a composite solid because we have the whole cylinder and we have this cylinder inside that is taken out. You think of a water bottle that has something in it to keep things cold, that is a cylinder itself that's frozen. Okay, I'm taking that volume out of my shape. So I take the larger thing, pi r squared h, which is pi 3 squared times 7, minus the smaller one, which is pi 1 squared times 7. So I have 63 minus pi minus 7 pi. So again, 56 pi is an acceptable answer there. Or I can multiply that out and get 175.93 millimeters cubed. Right? And you could multiply these out and deal with the decimal here if you're going to get this anyway. I like leaving it in terms of pi because 3 squared is 9. 9 times 7 is 63. 1 squared is 1. 1 times 7 is 7. I don't need to pull out my calculator. Whereas as soon as I introduce pi, I need to pull out my calculator because I'm not doing 3.14 times 63 in my head. Then the bottom of the sheet, what we're looking at is similar shapes. Right? So similar solids, two solids of the same type with equal ratios of corresponding linear measures, such as height or radius. All right? So same type, it's not just prism and cylinder, it would mean like triangular pyramid or a triangular prism or a rectangular prism, and your side lengths would all need to match up, right? Not to be equal, but to reduce to the same thing, right? If two similar solids have a scale factor of a to b, then they have corresponding areas of a squared to b squared. Looked at that earlier in the year, and corresponding volumes have a ratio of a cubed to b cubed. Okay? So when I'm comparing my shapes, if I have a cube that has sides of 1 and another cube that has all sides of 3, my scale factor would be 1 to 3. right? My area of those would rate, the ratio of that would be 1 to 9. That does not mean the areas are 1 and 9, it means that's the ratio. And the ratio of volume would be 1 to 27, 3 times 3 times 3. Okay. So looking at some examples here of what these problems can look like. Example 2 says cylinders AB with a scale factor of 2 to 5. All right, find the surface area and volume of cylinder B, given that the surface area of A is 96 pi square feet, and the volume of cylinder A is 128 pi cubic feet. All right, so what I want to do here is convert my scale factor and then use that to find my area and volume. So here we have, oh, there we are. Here we have our area, so 2 to 5, we're squaring it. So I have 4 to 25. So then I'm going to set up a ratio. The smaller one is A, which is what they give me. So I have 96 pi on top. The larger one here is what I'm looking for, so I put that on the bottom. Cross multiply, so I get 4x equals 2,400 pi, which is 25 times 96. Divide by 4, and I get 600 pi. Again, I would leave it like that if you're not comfortable with that. This would be our decimal, 1,884.96 feet squared. But I think 600 pi is easier. Then the volume, right? We're now cubing this for volume, so I have 8 to 125. Watch what they're giving you. Sometimes they'll switch these up. In this case, they're still giving me A, so that is still on top. So I have 128 pi, cross multiply 8y, or 8 times the volume, equals 16,000 pi. Divide by 8, I get 2,000 pi as my answer. And again, if I multiply that out, I would get 6,283.19 feet cubed. And then our final problem, example 3, the volume of a right cylinder is 200 pi cubic centimeters. Find the value of x. All right, so I know my volume is 200 pi. That is equal to pi r squared times my height. So then divide by pi. So I have 200 equals r squared times 8. Divide by 8, r squared is 25, so my radius is 5. But do watch what they're asking for here. They asked me to find the value of x. X is the diameter. So I need to double that 5 to get that my x is 10.